Okay, this is the quiz that period 6 took, so I'm going to jump right into it. Again, I apologize for not being there. I'm going to factor the numerators of both of these. I do still see people splitting the middle and grouping, which you really don't have time to do. I also see a lot of people not checking their factors. So my hint would be, if you end up with a whole bunch of stuff that won't cancel, I would go back and check my factoring, because sometimes that means you just didn't factor it well. So now that I've factored, I'm going to cancel out the common factors in the numerator and the denominator. And what it looks like I have left is 2x, x minus 6, over x squared, x minus 3. And so now I have to talk to you about the difference between a term and a factor. A term is separated by addition and subtraction. Factors are kept together by multiplication. So right here, I have multiplying, multiplying, multiplying. So this is 2 times x minus 6. These are factors. It's one term. Same thing here. This is one term with x times x minus 3. So a factor of x can cancel with a factor of x, which would then leave me 2x minus 6 over x minus 3. Remember on the test to make sure you're talking to yourself about factors and terms. Going to do the same thing here. Going to factor the numerator and the denominator. Nope, that's not right. That would be x minus 7 and x minus 3. This is going to be x plus 2 and x minus 2. Okay, and a lot of people, and I understand it because we're in the habit right now of finding least common denominators, we're finding least common denominators on these first problems. Well, least common denominators are when I need to add and subtract two terms together. All I'm doing here is I'm multiplying. So now I can cancel out common factors. So this x minus 7 factor cancels, and this x minus 2 factor cancels, leaving me x plus 2 over x minus 3. Okay, so again, we're going to factor the numerator and the denominator, plus 6 plus 2. And this is going to be x plus 7, x minus 2. This is going to be x plus 6, x plus 4. But I think I'm going to do this all in one step. Dividing means flip and multiply, so I'm going to bring the numerator up to the denominator up to the numerator, and the numerator down to the denominator. So the denominator is going to factor as this, and this numerator is going to factor like this. Okay, and this is one of those times where I will cancel an x minus 2 and x minus 2 and x plus 6 and x plus 6, and nothing else cancels. And I definitely would say to myself, okay, I have two factors here, two factors here. Could I have factored something incorrectly so that more would cancel out? But that's not the case. So my answer here is going to be x plus 2, x plus 3. X plus 7, x plus 4. Same thing here. I'm going to factor the numerator and denominators. This is going to be x plus 6, x plus 3. This is the difference of squares, x plus 6, x minus 6. I'm going to flip and multiply by the x minus 9 over x plus 3. I'm now going to cancel out common factors of x plus 6 and x plus 3. Leaving me x minus 9 over x minus 6. A lot of you handed in this quiz early, and I just want to remind you, if I wanted to check this, I could type this whole thing in y1. So I could put the whole question in y1, and I could put the whole answer in y2. And if I simplified right in the table, this is going to be my x's, my y1 and my y2, these should match in here. One more thing I want to say is when you are doing these, please leave something like this up in this number 3. Please leave this factored. Don't multiply this out to x squared plus 5x plus 6. Don't multiply these out. Sometimes when you multiply them out, they will refactor and then cancel with the denominator, but these two are not going to cancel anything, so I'm just going to leave it. Okay, now you can see we're subtracting or we're adding. Now we have to find a common denominator. So the LCD here is going to be x minus 4, x plus 3. And I see that this first fraction needs to be multiplied by x minus plus 3, x plus 3. And this second fraction needs to be multiplied by x minus 4, x minus 4. Okay, I'm going to distribute in the numerator of this one. So the numerator, I'm going to get 4x plus 12. And now I'm going to actually distribute this negative 3 to both of these. Okay? Or you could leave this negative and distribute here. Let's do that. So I'm going to leave over my LCD minus, I'm going to distribute this and I'm going to combine like terms, and here's where everyone made their mistake. This is a minus 3x, so 4x minus 3x gives me an x. But this is 12 minus a negative 12, which would mean plus 12. So I have x plus 24 over the LCD. Now, some people canceled out the LCD because when we're solving, as soon as I have a common denominator across the equal sign, I can just solve the numerator. But when I am simplifying, I need to make sure I leave the denominator. So again, I could put this in y1 and this in y2 to check my answer in the table. Okay, in this next one, I have an LCD of x plus 5, x minus 5. This will factor to x plus 5, x minus 5. It's the difference of squares, which some of you did not pick up on. So the first fraction, the first term, is not missing anything. The second term is missing the x plus 5. And again, all I'm doing is simplifying, so now I'm combining like terms across the numerator. So I have 4x plus 3x, which will give me 7x. I have 5 plus 15, which will give me 20. There we go. So I just want to run back to this problem right here. And a lot of people are doing some great math, and then for some reason feeling like once they find the common denominator, then they cancel out that common factor in the numerator and denominator, which you can do, but if I cancel both of these out, I'm left with the same problem I started with. I cannot subtract now because I don't have a common denominator. So don't do this either. Okay, so let's move on to number 7. And again, I have two terms. This is a term, subtract, this is a term. And in order to subtract two terms, I have to have a least common denominator. The least common denominator here is going to be x plus 4. And this first term, 6, is missing that x plus 4. The second term isn't missing it. But what I want to point out is right now, everyone should be learning that if I have a subtraction sign, I should be slowing down and checking my work. I should make it a priority to check every single subtraction problem using y1 and y2 with my answer. So if I continue here, I have 6x minus 5. They're not like terms, so I have 6x. And then I have plus 24 minus 5, so plus 19, all over the LCD. And it doesn't matter if it's in parentheses or not, it can go either way. Okay, the next one. Okay, so we have a numerator with fractions in it and denominator with fractions in it. So we're going to look at the numerator first. I have 1 over x plus 3 over 2x plus 1. And the LCD of this has to be x times 2x plus 1. I can't make the LCD 2x plus 1 because how am I going to change this to 2x plus 1? Multiply by 2, I get 2x. Multiply by 3, I get 3x. I need this as a factor in the denominator and this as a factor in the denominator. So this first fraction is missing 2x plus 1. And the second is missing x. So I'm going to add across, and I will get 2x plus 3x plus 1 over x, 2x plus 1. So I added across the top. 2x plus 1 plus 3x gives me 5x plus 1. Okay, and now I'm going to deal with the denominator. So I've combined like terms and gotten them on common fractions and everything in the numerator. Now I'm going to go to the denominator. It's already just one fraction, so I'm going to flip and multiply. I'm going to multiply by 2x plus 1 over 5x. And I'm now going to cancel common terms, common factors. So this 2x plus 1 and this 2x plus 1 are common factors. If I were to cancel this and this, I would have just killed a cat. You canceled a term with a term. This is a term right here. 5x plus 1, term, term. Down here, 5 and x are both factors, but I can't cancel a factor and a term. So what I should have been left in the numerator was the whole 5x plus 1. In the denominator, I have this x and this 5x, so in the denominator I should have had 5x squared. And again, put y1, this whole thing, y2, this whole thing, and check the table. But don't kill cats. Okay, a farmer wants to fence in a garden as shown below. Write a simplified rational expression for the ratio of the garden's perimeter to its area. Okay, a rational expression, and we'll talk about that once we get to the answer, but ratio. I can either write a ratio as something to something, something to something, or something divided by something, right? And if I want an expression, these two would not be considered expression. I need this. I need a rational expression for the ratio of the perimeter to the area. The perimeter of this would be 4 times a side. The area would be 5x times 5x. This will give me 20x over 25x squared. I know that 5 goes into 20 4 times. I know that 5 goes into 25 5 times. I also know that this factor of x will cancel one of these factors of x, leaving me this as my rational expression. The next problem I am now solving, and a lot of you got very equal to subtracting it to the left side, setting it equal to 0. But remember, we're solving. We're not doing rational inequalities here. So I have two fractions. The easiest way here is to cross multiply. Numerator times denominator, numerator times denominator. So I'm going to have 18, and I'm going to change that. I'm going to have this numerator times the other denominator, and this equals the other numerator times the other denominator. Some of you are putting 18 x minus 1 over x plus 3, x plus 6. Sorry, minus 3. What do you set that equal to? Where did the equal sign go to? So that's incorrect. So we don't want to get in the habit of doing this. When you cross multiply, you can't ditch the equal sign. You have to have an equal sign to solve the equation. I'm going to distribute out. This is a quadratic. I'm going to set it equal to 0. And this is a quadratic. I have to factor. It has a GCF of x. I need to set this term equal to 0, and I need to set this term equal to 0. So this is x equals 0 and x equals 15 are my two solutions. So let's talk about a couple things. Some people were putting them in ordered pairs like this. Okay, remember, I'm looking for a solution to this. A solution is actually a number that I plug in for x in all three places, and I'm left with a true statement. An ordered pair is an x-intercept, and yes, that is a solution to this polynomial, this rational function, but I do not write it as an x-intercept now because I want the number that when I plug it in here and plug it in here and here, I get something equal to something that is true. Okay, this next one, there are a couple ways to solve this. The first way I could do this is to combine like terms on the left side, and I would get x minus 3x, so negative 2x, and then I would get negative 6 minus negative 2, so that's minus 4, all over x minus 4, because they already have a common denominator, equals 4. And I could put this over 1, and I could now cross multiply. I could do it that way. Or I can notice that the common denominator is going to be x minus 4, and this term over here is missing an x minus 4. So I could multiply this by x minus 4 over x minus 4, and then all I need to do is I just need to solve the numerator. And I get, again, I still have x minus 3x here, so I get the same thing on the left, and I get 4. I'm going to go ahead and multiply that out on the right. And notice if I did it the other way, I would get negative 2x minus 4 equals 4x minus 16. Same thing. I'm going to add this 2x over here to this side, and I'm going to add the 16 over here, and I'm going to get x equals 2. And now to check answers, don't forget it's not y1, y2. To check answers, what I would do here is do store x and type in this side of the equation, the whole thing, and just that 4 right there. Actually, I don't need to do that. I could type in just this side of the equation, and when I pressed enter, it better give me 4 as an output. Okay, if I look at all of these, again, they're not inequalities, so I don't have to set this all equal to 0. I can just solve it as it is. I know that this particular term is over 1, and I see that my LCD is going to be 12. So I'm going to multiply this guy by 4 over 4, this guy by 3 over 3, and this guy by 12 over 12. And all of this is going to be in parentheses. And what I would get is, I'm going to distribute that 4, I will get 20x plus 24 over 12 equals 30 minus 12x over 12 plus 48 over 12. since I have a common denominator, I can now ditch the denominator and just solve the numerator. And I will get 20x plus 24 equals 78 minus 12x. Add the 12x over here, subtract the 24 over here, divide, and I'm going to get x equals 54 over 32. And this fraction will simplify as 27 over 16, or I can round to 1.688. Remember, 3 decimals, unless you are asked for an exact answer. And then I would have left it 1.6875, but 3 decimals. Okay, last one. If I factor everything out, I'm going to have this. Okay, and you guys remember, this is not inequalities. I don't need to set them equal to 0. I just need to get a common denominator across the equal sign. So I know the common denominator is x plus 3, x minus 2. So I'm going to multiply the terms by what they're missing in the denominator. Okay, I think you already know the answer to this, but if I factor this incorrectly, can I get a correct answer? No. So make sure when you're factoring, you're getting the correct answer. Okay, so now my numerator would be 2x minus 4 plus x plus 3 equals 6. And I can ditch the denominator. I get 3x minus 1 equals 6, 3x equals 7, x equals 7/3. Store as x and check your answer. X equals 7/3. All right, on number 14, again, a couple different ways you can solve it. I think probably the easiest is to notice that if I move this term over to this side of the equation, I will have a fraction equals a fraction, a proportion. So I could just cross multiply. I think that would be the easiest to do. I will get 5 over x plus 4 equals 1 over x minus 3. Cross multiply, I get 5x minus 15 equals x plus 4. Subtract the x, add the 15, and I get x equals 19 over 4. Okay, now, could I have found the common denominator across? Yes, which means that the LCD would have been x plus 4, x minus 3, and I would have multiplied this numerator and denominator by x minus 3, this numerator and denominator by x plus 4, and this side by both, but 0 times anything is going to be 0. So I'm going to end up with 5x minus 15. I have to distribute the negative 1 times the x, so I get negative x. Distribute the negative 1 times the 4, so I get minus 4 equals 0. I'm going to combine the x's to get 4x. I'm going to combine the 15 and the minus 4, and I'm going to add it to the other side. And again, I'm going to get x equals 19 over 4. Last problem, LCD. Okay, this again was confusing, like number 8. We have a denominator with a factor of x and a denominator with a factor of x plus x minus 1. So my LCD has to be the factor of x and the factor of x minus 1. I can't miraculously turn this x into an x minus 1 by multiplying by negative 1. I would get negative 1x. I can't subtract 1 to numerator and denominator. That doesn't work that way. I can multiply by something. So I have to have a factor of x and x minus 1. So what I have is and the first fraction is missing the x minus 1. The second fraction is missing just the x. The third fraction is missing the x and the x minus 1. Now that I have a common denominator, xx minus 1, xx minus 1, xx minus 1, I can just concentrate on the numerator. This first one will distribute the 1, yay. I'm going to distribute an x here. I'm going to get negative x squared plus x. I'm going to distribute 2x, because if I multiply the 2 times the x, I'm now distributing 2x. So I'm going to get plus 2x squared minus 2x. And I'll do this in a couple steps. So if I combine the negative x squared and the 2, I get an x squared. X minus 2x is minus x. Now it's a quadratic. If I go ahead and set this equal to 0 and factor, I'm going to subtract that x over. I'm going to get 0 equals x squared minus 2x minus 1 plus 1. Sorry, I'm adding this 1 across. A lot of you made that mistake because then it made this infactorable. So this is going to factor as x minus 1, x minus 1. So my solution is going to be x positive 1. But if you notice, if I take this positive 1 and put it in that denominator right there, I'm going to be dividing by 0. So the answer is extraneous solution. I do not write no solution because if I solve, I get a solution of x equals 1. But if I plug it into this particular equation, it's not going to work, so it's called an extraneous solution. So when we come back, I get to finally clean off that board on the right side of the room. I hope you guys have a great 3-day weekend. I am looking forward to playing my iPhone games again. And I'm sure some of you are looking forward to sweets. I will think about you when I am at the Cupcake ATM in Atlanta. You guys have a super fantastic 3-day weekend. I will see you Monday. Happy Easter. Please remember that the test is Monday. Do not wait till Monday morning to study for it. What will be on the test that is not on the quiz will be radical inequalities and word problems. Make sure you look at all of that. Bye, guys.